In this video, I will be solving the following question. Hello everyone, in this video I will solve a monopoly problem for a unit demand setting. So a unit demand setting is special, is when all your customers want to buy just one unit and this unit is indivisible. A good example of such market is, let's say, when you shop for a car. As a customer, you want the whole car, you don't want half a car. And usually, at least regular consumers, not firms, regular consumers, at one point just buy one car. So that's potentially a nice mental example to have in your head when you think about this problem. So here we will have the following characteristics. So we have 7 consumers. So we have consumers, and there are 7 of them, and they will be ranked by their willingness to pay, maximum price they're willing to pay for the car. First one, 21, 18, 15, 12, 9, 6, 9, 6, and our last customer is 3. Our monopoly, and monopoly can produce cars at the cost of 5 per each unit. So its cost is 5, its marginal cost is just 5. Okay, so we will solve this problem for 3 scenarios. The first one, we will find social optimum. Essentially, from a social point of view, how many cars this monopolist should actually produce and supply. Then we will solve a standard monopoly, where monopoly charges the same price to every consumer. And finally, we will solve first-degree price discrimination. In this context, it also will be third-degree price discrimination when the monopoly is allowed to charge different price to each consumer. So a social optimum. It's very convenient usually to order this customers in the descending order, the way I already did. So let's copy these numbers. 6, 3. The cost of producing these cars is so that's our values. The cost of producing car is 5 for each, right? Therefore, 5, 5, 5, 5, 5, 5, 5. And from social perspective, we should supply the car if value it creates is higher than it costs us to produce it. So in this problem, it's very easy, right? We should serve 6 customers because for all these first 6 customers, their value exceeds the cost of making this car. For the last customer, it's the opposite. It only values car at 3. It costs us 5 to produce, so we should not serve this customer. So social optimum will be 6 cars, and let's calculate social welfare here. Total value created. That will be just the difference on each car you make. So for example, for the first one, it's 16. Let's actually, social value created, 16 here, 13 here, 10, 7, 4, and 1. So a total social welfare will be just the sum of all these numbers here, and so 20, 30, 46, 51. And there is no deadweight loss here because it's social optimum. Okay, so now let's solve this problem for the when firm actually operates as a monopoly and maximizes its profit using a linear price. It's not allowed to discriminate. Okay, so let me just copy social optimum 6, social welfare is 51. That it mostly can memorize, and I just want to keep my table here. So B, linear pricing, So let me erase this column. And now we will be calculating marginal revenue of the consumer. So what a monopolist will do here is very simple. If he decides to sell one car, it can charge up to 21. So that's the optimal price to charge. If you decide to sell one car, 21. If you decide to charge two cars, your price cannot be more than 18. Obviously, the monopolist then will set it to 18, and so on. So let's calculate revenue and then marginal revenue. So our revenue for each case, so if monopolist only sells one car, its revenue will be 21. If he decides to sell two cars, its revenue will be, he will have to charge price of 18, so it will be 36. If he sells three cars, 45, four cars, 48, that's 4, 5 is 45. We can see that it becomes decreasing even here. So obviously the monopoly wouldn't even go there. For 6 cars it will be, then the price must be 6, so it's 36. And for 7 cars the price would have to be 3, so it's 21. So for monopolists to determine what's optimal, you have to compare marginal revenue and marginal cost. So let's do marginal revenue. So here it's 21. So for the first car, here the revenue goes from 0 to 21. So here it goes from 21 to 36, so that's 15, correct? Yes. From 36 to 49, it's 9. And from 45 to 48, it's 3. And in some sense, we should stop already. After that, profits start to decrease. And we need to compare marginal cost and marginal revenue. So notice that for the fourth car, your cost is 5, marginal revenue is 3, so you're not doing that. Then the monopolist should sell 3 cars only, kind of get it up to this point. And now let's calculate profits. So monopoly profit will be, okay, so price will be 15. This is the price he will charge. So basically anyone can buy at 15. There only will be 3 customers. So his monopoly profit will be 3 times 15 minus 3 times 5, because it costs him 5 to produce each one. Therefore, that's 30. Consumer surplus. For the first consumer, he will buy a car at 15. His value is 21. So his value is 6. Consumer surplus for the second guy, 18 minus 15, that's 3. And third guy is squeezed out completely. Note for any other consumer surpluses 4 and above, it's all 0 because they're not getting their cars at all. So total consumer surplus will be 9. Monopoly profit is 30, so social welfare is 39. And we can see comparing to social welfare here that deadweight loss is 12. So because of monopoly power, because our monopoly wants to make money, it will actually will serve only, instead of serving 6 customers, will serve 3 and charge a much higher price, resulting in most of the economic pie going to the monopoly. And finally, first degree price discrimination, or in this context also third degree, because they're equivalent in a unit demand setting. So first degree price discrimination. So in this case, our monopoly is allowed to charge different price to every consumer. Therefore, it doesn't really have to drop its price here in order to serve more customers. It can simply charge, if it wants to sell a car to the first guy, it will say, well, your price is 21. For the second guy, your price is 18, and so on. And for the first degree price discrimination, the general result is that monopoly will just replicate social optimal outcome and take all the money. So then what will happen here? It will serve 6 customers. The prices will be individual for each one. So P3 will be 15, P4 will be 12, P5 will be 9, P6 will be 6. The profit of the monopolist will be, we can calculate it, but it will be 51 eventually. So it will You can just add up all these numbers and then subtract 30, because that's how much it costs monopolies to produce cars. We already been doing it. We did it when we were calculating social optimal outcome. In this case, of course, CS will be 0 for all I, for all 6 customers, and for 7th, who is not served, all of their consumer surpluses will be 0, and there will be no deadweight loss. Again, standard result, because we allow monopolies to price discriminate perfectly, it can capture all economic pie, therefore there is no need to create any deadweight loss. Thank you.